Okay, children, so this is your Unit 3, Day 5 lesson video. In it, we're going to start discussing actual, more quantifiable measurements of space and not so abstract anymore. We're going to start applying trig to a bunch of other things, including things that you're very familiar with, like circumference and perimeter. Okay, so REQs, how can we define a circle on the Cartesian plane? What are the regular and non-regular polygons? What is perimeter? What is circumference? And how are the two related? So let's go ahead and get started. So right off the bat, let's talk about how we can define a circle on the Cartesian coordinate plane. And the answer is actually pretty simple if you stare at the picture long enough. So here's our radius, right? Our radius is like the hypotenuse of a right triangle here, okay? And obviously here's our x-axis, our y-axis, yada, yada. So that means our coordinates for this point right here are xy, meaning the distance between the center of our circle and the edge of the radius onto the circle itself, right? The distance is equal to the radius. Okay, so if I wanted to say, our radius equals something, right? I could simply think of it in terms of the Pythagorean theorem. So the radius squared, or c squared, hypotenuse squared, whatever, is equal to leg squared plus leg squared. Okay, so hypotenuse equals leg squared plus leg squared. And I'm not going to go too much further into the algebra behind this, because there's an extra credit question that I've posed to you on the Do Now if you haven't seen it already. So this is about as far as I'm going to go, but this is our answer to EQ1. This is how we can define a circle on the Cartesian coordinate plane. We'll go into more depth if time is willing. So let's go ahead and get into EQ2. So for EQ2, this is very simple, very, very simple. What are regular polygons? Well, basically, they're just polygons. So here's your definition. Here's your definition of just the word polygon, right? Your definition of just the word polygon is right there. Closed two-dimensional figure. That is literally a polygon. Anyway, a regular polygon is a polygon whose side lengths are congruent. A non-regular polygon is a polygon whose side lengths are not congruent. Okay, so very simple. And if you need to just pause this and write that down, do whatever you're going to do. Okay, so now let's start applying the concepts of perimeter and circumference. So they're both, especially perimeter, very, very intuitive. So what is perimeter? So let's go ahead and define that literally. Perimeter is the one-dimensional linear distance around a 2D figure. Okay, and to say that even shorter, perimeter is a one-dimensional measure of a two-dimensional figure. Okay, so anything one-dimensional is linear, anything distance-related is linear, so it's one-dimensional. Okay, so let's go ahead and answer a little bit more in depth. Well, what is perimeter? So let's look at this example I made up here. So a rancher is wanting to enclose a rectangular area of land that is 100 yards long and 200 yards wide for rodeo grounds, for bull riding, barrel racing, etc. So if you're familiar with any of that kind of stuff, that'll make sense to you. How much fence will he need to enclose this area? Okay, so that's a very simple concept here. All this is asking is for the perimeter. Okay, so the perimeter around this enclosed area is going to tell us how much fencing he needs to enclose the area. And that's very simple. So if this is a rectangle, if this is indeed a rectangle, that means this side is also 200 and this side is also 100. So our perimeter is simply equal to the distance from here all the way around back to here where we started. Okay, so that would be 100 plus 200 plus 100 plus 200 again. So that's 400, 500, 600. So he needs 600 feet of fencing. Okay, if the fencing costs $10 per yard, right, how much is he going to have to pay? Well, our cost is simply $10 times the amount of fence per foot, right? And that would simply be $6,000. Pretty good amount of money there for that much fencing, but it is a pretty large area. Okay, so the same rancher now wants to build a circular area of fence to keep calves. He's going to use 300 yards of fencing. Okay, so circular area, right? And the distance from here all the way around is going to be 300 feet. Okay, 300 yards of fencing to enclose this area. He wants to be able to split the circular area in half with more fencing later on. And he measured it out to be approximately, so if this is the center here, he measured it out from a point on the fence through the center, clear to the other side, to be 95.49 yards. Okay, that is our distance here. And there's a special name for that we'll get to here in a second. Okay, so what is the diameter? So there's the word that we were looking for. What is our diameter of this enclosed area? Well, we have it right here. Okay, diameter is a line that passes from one end of a circle through the center and through to the other side of the circle. Okay, so our diameter is 95.49 yards. Okay, what is the radius of this enclosed area? Well, that's also very simple. The radius is simply equal to the diameter cut in half, or half the diameter. So all we would need to do there is divide that by 2. So if I take a calculator and just do 95.49 divided by 2, I get 47.75 about yards. Okay, and the definition of a radius is very simple. The definition of a radius, all that is the distance from the center of a circle out to the circle itself. This is your radius. Okay, and the mathematical way to define the radius, besides what I just said, would also just to be able to say that it's half of the diameter. Okay, now here's another important question. What is the ratio of the fence's perimeter to its diameter? So its perimeter, quote unquote, is 300 yards. Okay, so perimeter equals 300 yards. Well, what is the ratio of the perimeter to its diameter, which is approximately, got to use the squigglies there, approximately 95.49. So we're wanting to know, well, P to D, or P over D, right? So to do that, all we're going to do is divide. That literally gives me the ratio of perimeter to diameter. So I'm going to say 300 over 95.49. And that's what I'm going to throw in my calculator. And I don't need the squigglies there. If I'm writing the actual rational expression, I need the squigglies after. Okay, and if you enter this into the calculator, you'll get that our perimeter over the diameter is approximately equal to 3.14. That number should look familiar. Okay, that number should look familiar. It is precisely pi. Okay, so the ratio of our perimeter to the diameter, and this is a circle, mind you, right? The ratio of perimeter to diameter is pi. Okay, so we're just going to say that it's pi. Now, there's another name for the perimeter of a circle, and that is circumference. So to answer EQ4, what is circumference? It's simply the perimeter of a circle. Okay, now let's go further in depth on that. So diving into EQ5, how are perimeter and circumference related? Well, they're both one-dimensional distances around a two-dimensional figure. Okay, but let's relate them closely and see where you may already remember what the formula for circumference is. Okay, so in the last problem that we were looking at, this is going to look familiar, we had perimeter, which is the same thing as circumference, was equal to, well, we don't know. But we did know if we said perimeter over diameter or circumference over diameter, that was equal to pi. So if we wanted to solve this equation here for circumference, right, we would simply multiply both sides by diameter. So if I take c over d equals pi, multiply both sides by diameter times d divided by d, those cancel, c equals the diameter times pi, or circumference equals the diameter times pi. And we also know the diameter is equal to 2r. So we could also say circumference is equal to 2 pi r. That ought to look pretty dang familiar there. Okay, so I digress. Let me get back to my point and show you where this actually comes from a little bit. Or this is one interpretation of where it could come from. Okay, so all of these polygons here, they're all regular polygons. Oh God, that was supposed to be a Y. They're all regular polygons, meaning all of their sides are the same length. Okay, and you'll notice n is the number of vertices on each one. So a regular triangle, aka an equilateral triangle, has 3 vertices. Okay, a regular quadrilateral, aka a square, it's going to have 4 vertices. And then here we see n equals 7. This is called a regular septagon. Okay, a septagon is any 7-sided polygon, but this one's regular because all of its sides are the same length. Okay, this guy here, and I forget the name of this, but this is a 12-sided polygon, and it's a regular polygon because, you know, that's the whole point of this right now. I believe it's dodecagon. Anyway, a 12-sided polygon is called a dodecagon, and this is a regular dodecagon because all 12 sides are the same length. Okay, this guy here is an infinitely sided, or it has infinite vertices, right? It's an infinitely sided regular polygon, aka a circle. Okay, so let's keep that in mind here. Okay, so we're gonna have a couple new definitions here in a second. So first, let's look at this. So the distance from the symmetrical center of a polygon out to the midpoint of one of its sides, and we're talking about regular polygons still, so I should go ahead and say that. So the distance from the center, the symmetrical center of a regular polygon to the midpoint of one of its sides, and we're going to use the letter alpha, the Greek letter alpha. Anyway, this is called the apothem. Okay, the apothem is the distance from the center of a regular polygon out to the midpoint of one of its sides. Okay, the radius, however, of a regular polygon is the distance from its center, still from the center, to a vertex. Okay? Now, let's go ahead and just call this guy here in green. This distance between those two, between the midpoint and the vertex, we're just going to call it K. All right, and I'm going to erase a little bit just so I can have some room to do some quick maths. Okay, so there are some parallels here between a regular polygon with a whole bunch of sides and a circle. Okay, and obviously one of them is that they both have a radius. Okay, if a circle has an infinite number of vertices, right, its radius either goes, so this is what we can say about a circle, right? So as the length of our radius approaches the length of our apothem, right, we can say that the length of K, that is this guy right over here, we can say that the length of K approaches 0. Okay, we can also say that in the number of sides approaches infinity, or the number of vertices. They're equal to the same number. Okay, so what does that all mean? Well, let's throw an angle on here. Let's call this angle right here just theta. Okay, like we always do, just pretending we don't know what it is, which we don't. We could calculate it, but not going to get into that yet. Anyway, we could easily find theta using trig. Okay, and we could just use cosine. Cosine of theta is equal to adjacent over hypotenuse. Okay, do some quick math, throw this stuff around. We end up with the length of k is equal to r cosine theta. The length of our radius times the cosine of the angle theta. Okay, so pretty straightforward there. Now, let's look again at our, Let's look again at our formula for the perimeter of a regular polygon. So I'm going to put P reg for regular polygon. And that's simply equal to x times n, the number of vertices, right? So, what have we got? We can go ahead and say that k, if you do 2 times k, that's equal to x, the length of the side of this guy right here, right? So we can say x equals 2k. And we know that k equals r cosine theta. So we can go ahead and substitute a little bit. So instead of x times n, we can say that we've got 2 times k times n, right? We substituted x for the fact that it is 2 times k. Okay? And we can substitute 2k because we know we know k is r cosine theta. So we can say 2 times r times cosine theta times n is equal to our perimeter, right? 2 times r. Well, we just learned something earlier, right? Our diameter is 2 times the radius. Okay, so coming back to here, we can just say 2r is the diameter, cosine theta times n, and that's equal to our perimeter, right? Well, another thing that we can go ahead and do, and I know this is getting kind of lengthy, if we divide both sides of this equation by the diameter, we have perimeter divided by diameter, that should look familiar, equals cosine theta times n. Okay, so let's back up over here to this nonsense here. So as the number of sides approaches infinity, the length of k approaches 0. And somewhere along the lines, if you multiply those two, you'll start approaching a value, right? And that's given by this right here. The ratio of perimeter to diameter, we know that that is pi. Okay? So as n approaches infinity, k approaches 0. If you multiply those two, apparently, you get pi. So pi is equal to the cosine of our angle times the number of vertices. Okay? So we can go ahead and go back, and let me use a different color. We can go ahead and go back and replace cosine theta times n right here with this guy. Okay, we can go ahead and replace that. And running out of room here, I'll just come into the circle. What we end up with is that our perimeter of our circle now, we're talking about our circle, is equal to, obviously it's equal to circumference, and we can say it's 2r, and if we replace it with, if we replace the cosine theta times n with pi, holy dog crap, we arrive at 2 pi r. Okay, so just a little bit of, hindsight on where this all comes from. So we have effectively answered all of our EQs and then some. Now all that's left to do is basically start on the applied practice and or ask me any questions that you have. If you do have any questions, you guys already know, shoot me an email. Otherwise, goodbye.